I want to do a Thevenin's theorem example problem here, and let's say in the theory I was talking about that we want to know the current through R5, but here let's change it and let's say we are interested in current through I4. That means through the resistance R4. So what we will do, we will open the circuit here, we will leave it, disconnect it here, so that will go away. This one is removed, and when it's removed we have an open circuit there, so it's like this one. So first we need to find the equivalent. Let's find R Thevenin first. So in order to do that, we have to make the sources inactive. So of course the voltage source here is short circuited, R4, R1, R2. This one is open here, current source. This is R3, and the R5 is here. So this is where I need to find the Thevenin's resistance. Now we can see there is a break in the circuit here, so the resistance will be R5. R Thevenin will be R5, because if the concept of finding equivalent resistance is if a source is connected here, what resistance it will see. That's the concept of finding equivalent resistance. If a source is connected here, what resistance, what is the equivalent resistance the source will experience. But since there is a break here, no current goes this way, so basically the resistance is, there is no return path for the current. Actually there is no path to go for the current to even go in from the positive terminal towards this direction, so the only resistance is here. So R5 is the only equivalent resistance. So the Thevenin resistance is just R5. Now we have to look at the Thevenin's the open circuit voltage. So let's do that. I will erase this part, and then we will have to, there are two sources, so what I prefer doing here is applying superposition theorem, principle of superposition, and let's see what happens with that. So first, if we consider the voltage source, it becomes like that, and when we consider the voltage source, again the current source has to be inactive, so it's again open circuit, and then we will see what is the equivalent the open circuit voltage here in this terminal AB, if we call it AB. So that one, since this is ES and this is R1, R2, so there is again this only one source, so the current flows in that way, and so the voltage here is basically R ES R2 R1 plus R2. So from voltage divider rule we can see that this will be the voltage here, which is this terminal, and this terminal. But since there is a break in the circuit here, there the VAB is, there is no VAB. VAB will be 0 for this one, and also there is no voltage drop across this terminal. So from that we can see that the voltage, there is no current flow here, and the voltage across this one will be just 0. So for that one, this is done. Now when the current source comes, we can, actually I will just do it here instead of redrawing it. So this is now short circuit and the current source is staying there. So this is, now we want to find the open circuit voltage due to the current source, and what happens is the voltage source is now short circuit and current source is there. Now it's a current source, so we already know the current through R5, and that will be just IS into R5. So VAB, which is the VOC there, will be just IS times R5. So that's how we already know what is the VOC. So this is this will be our Thevenin's voltage because the previous one was 0. So that's how we can find the, that's the VThevenin. So it's IS into R5. So that's the circuit becomes like that. So V Thevenin is this one, and R Thevenin, as we saw before, it's just R5, and then we can connect the resistance which is R4 there to find the current through it.